As you learn more and more chemistry, you're going to realize that the periodic table is one of the most useful tools at your disposal. And when it comes to the periodic table, the charges of elements is incredibly important to know. Now, group 8A, which is this column right here, are referred to as your noble gases. They are perfect because they have the correct number of electrons, or the most optimal number of electrons, in their shells. All other elements are trying to become just like them. Now, notice here that columns 5, 6, and 7, they typically have negative charges. Negative charges implies that they like to gain electrons. By gaining electrons, they become that much closer to becoming a noble gas. For example, fluorine here, it just needs one more electron to become just like neon. So, elements from that column tend to gain one electron. Elements in group 6A are 2 away from being a noble gas, so they'll gain 2. And then elements in group 5A gain 3 electrons typically to become just like a noble gas. But those are easy to determine. This video really is centering around the metals, the elements that have positive charges. And more importantly, we need to realize that some metals have one charge and that's it, while others may have multiple charges. For example, aluminum, which is in group 3A, has a charge of +3. If a metal has only one charge, it's typically called a type 1 metal. And because it's a type 1 metal, we do not need to use Roman numerals when trying to name a compound that contains aluminum. But other elements tend to have multiple charges. Tin, for example, can be +2 or +4. Because it has multiple charges, we refer to these types of metals as type 2 metals. Type 2 metals, because they have multiple charges, we must use Roman numerals when trying to describe which particular form we're dealing with. We're going to say here that multiple charges are very common when it comes to the transition metals of the periodic table. So your transition metals are the ones here in this pit. And although tin and lead are not transition metals, they act like it, they have multiple charges. So they would use Roman numerals when we're trying to name them. We're going to say here there are also some transition metals that have only one charge. Those include silver, which is always +1, cadmium, which is +2, zinc, which is +2, and the lesser known scandium, which is +3. Those have only one charge, so they do not use Roman numerals when we're trying to describe which form we're dealing with. And if you take a look here at this chart, here we have the common types of transition metals found within this first column. And here we see the distribution of their charges. You can see that scandium, right here, it has a charge of, it's either neutral or when it gains a charge it's +3. And then zinc, it's either neutral or when it has a charge it's +2. Look at all the other transition metals. They all have multiple charges. This is typical for a majority of the transition metals, except for the 4 that we've marked. And if you look, you can see that manganese is basically the king of variable charges. It can be neutral, or it can go from +1 all the way to +7. That's why it's essential to be able to use Roman numerals when describing the different types of charges that are common to elements within the periodic table. So just remember, groups have charges associated with them because they're trying to either lose electrons or gain electrons to become like the noble gases. Those that are positive tend to be the metals. They rather lose electrons to become noble gases. Non-metals, they're negative when they're gaining electrons so that they can become noble gases. And remember, if a metal possesses only one charge, it's a type 1 metal. But if it possesses more than one charge, then it is a type 2 metal. And we have to use Roman numerals when we're describing which particular charge we're dealing with.